Well, hello everyone. Good afternoon. I guess unless you're on the West Coast, good morning. We thank you for taking some time out of your day to join us for our February webinar, handling relational data in a distributed cache. It's been a popular topic in the past, and it always comes up with our customers as we're working with them. So, figured this was a good topic for this month. My name is Adam. I am a regional director of service delivery. So, in layman's terms, I'm a liaison or middleman between our customers and our internal NCache engineering team. With me is my associate Ron. He is our lead solutions architect. Ron works very closely with our customers across many different formats, between demos such or webinars such as this, one-on-one technical demos, configuration sessions, so on and so forth. But due to the fact he works with our customers very closely, he's very pivotal in our roadmap and strategy on where we take our scalability solution. So you're in good hands. During the presentation, if there's any questions about the content whatsoever, don't hesitate to interrupt us. Let us know. There's a questions tab in the webinar pane on your computer screen. I'll be monitoring that. So any questions, let us know. That's what we're here for. And with that, I'm gonna pass it over to Ron, and we'll get it started. Thanks.
Well, thank you very much, Adam. Hi, everybody. My name is Ron. I'll be your presenter for today's webinar. And as Adam suggested, today's topic is how to handle relational data in distributed caching system. So this is one of very important topics. This is one of the questions that we get asked quite a lot, and I'll talk about having a distributed caching in place when you have a relational database. You have some challenges, some performance issues, some scalability issues, and then you transition into using a distributed cache along with the relational database. What are the challenges that you get and how to manage those challenges? So that's what we have in agenda for today's webinar. It's going to be pretty hands-on. I would show you some code examples. I'll talk about some real life. I have some examples lined up which I'll actually use to demonstrate this, and then towards the end I would also have a hands-on portion to go over some basic NCache configurations. NCache, that's the main distributed caching product. We'll be using that as an example product for this particular webinar, but overall it's a general topic webinar where we have our relational data in the database, and then you have a distributed cache, how to transition and start using distributed cache within the relational data which has relationships, and that's a structured data. So let's actually go through this. So first of all, I'll talk about scalability, the concept of scalability. Scalability is an ability within the application where you can increase the transactional load, where you can handle more and more request load out of the application architecture, and you don't compromise on the performance. So if you have a high throughput and low latency, that ability is called scalability. So you can handle huge amount of request loads, and individual request performance does not go down. It's same, and with more resources you can even increase that. And linear scalability is an associated term which allows you to actually scale out, where you have more and more request load handling capacity introduced into the system by adding more servers in most cases, and the performance does not go down. So if you have low latency and you have a linear improvement in the request load, previously you were handling say 10,000 requests per second, or even for 5 users you have certain amount of latency, say a few milliseconds or some millisecond response times for 5 users. You should have the same kind of responses, same kind of performance, same kind of latency for 5,000 users or 50,000 users. And that ability to keep on increasing the user load and their associated request load, that's called linear scalability. So what are the typical applications that need scalability? It's going to be your ASP.NET web applications, Java web applications, or even .NET web applications, general web applications which are public facing. It could be an e-commerce system, it could be an airline ticketing system, a booking system, or it could be a financial service or a healthcare service which has a lot of users actually using it. It's public facing. It could be web services, WCF, or any other communication service which is interacting with some data access layers, or is dealing with some front-end applications, but it may be handling millions of requests at any given point in time. It could be Internet of Things, some backend devices, backend data that or some task processing for those devices. So it could have a lot of request load. Big data processing, that's common buzzword these days, where we have a lot of small inexpensive compute servers, and through distribution of data on multiple servers you actually process huge amount of data loads. And similarly there would be huge amount of request load for that particular data. And then it could be any other general server applications and tier applications which may be handling millions of requests and a lot of users. So those are the prime candidates for scalability. Those are the applications which need scalability within the architecture. This is a typical diagram. What is the scalability bottleneck? So these are the applications by design. These frameworks are very scalable. ASP.NET web form or WCF web form. There are options that you can use to scale out these systems, but they all talk to a backend database, and typically it's a relational database. It could also be ASP.NET session storage or a mainframe or a file system, but that's not what we're covering in today's webinar. Today's webinar is more focused on relational data. So relational data is a single source. Although you have a very scalable platform right here, you can add more and more servers on this tier. You can scale out by putting a load balancer in front, and that load balancer can route requests between different servers. But all of these web servers end up talking to a database tier which is not that scalable. So that's going to be a source of contention. It is going to be slow to start off, and then it cannot scale out. It's a single source. There's no option of adding more and more database servers to actually increase the capacity of requests. So the capacity of requests can max out, and that can actually lead to high latency. So it's a capacity issue for request handling, and it could also end up into a latency issue. So it can choke down the system when you have huge request load. So that's the main problem with relational data sources, and solution to that is very simple, that you start using a distributed cache. A distributed caching system like NCache, which is super fast because it's in memory in comparison, and then it's linearly scalable. It's not just single server, it's multiple server environment where we have a team of servers joined together into a capacity. You pool their memory capacity as well as their transactional capacity, and you get a very linearly scalable model out of it. And NCache is exactly that kind of solution which you can use to handle database scalability issues. What is a general in-memory distributed caching system like NCache? What are the characteristics? It's going to be a cluster of multiple inexpensive cache servers which are joined together into a logical capacity. So this is an example of it. You can have 2 to 3 caching servers. For NCache, you can use Windows 2008, 2012, 2016 environment. Only prereq for NCache is .NET 4, and it's a middle tier between your application and the database, and it's very scalable as compared to your database tier, but it's something which would give you the same kind of scalability that you would get from ASP.NET Web Form or WCF Web Services Web Form. synchronizes cache updates across all cache servers, so data consistency is built into the protocol. All updates are applied in an atomic manner with an understanding of consistent data view for all the clients which are connected to it. It should scale out linearly for transactional as well as for memory capacity. You simply add more servers and it should grow the capacity in response to that. If you have 2 servers and you add 3rd and 4th server, it should essentially double the capacity of that system now that you have double the amount of servers. So that's what NCache offers as well. And then replication is another feature for reliability. Any server going down, first of all, it should not have any data loss or downtime. It should be highly available, highly reliable system, and that's what NCache takes care of. So having discussed this, that you have a scalability issue with relational data sources, and distributed caching systems like NCache is a solution to that, and that becomes a central tier between your application and the database. And your data exists from 2 places. You have data in the database, and then you have data in the distributed cache. So and NCache also manages some synchronization challenges that you may have when you have data on 2 different sources. There's a separate webinar on this topic, but just to let you know that there are some data access layer providers. There are some change notification dependencies which you can set up. So any change in the database can trigger an invalidation or update of items in the cache, and similarly any changes or updates that happen in the cache can be applied on the database. So this can be achieved with the help of our data access layer providers, read through and write through, and then we also have some database change dependencies, record change dependencies, which we actually use to ensure 100% synchronization between database and the cache records. But typically data exists on two different places. You have data in the cache, which is usually a subset of the data, and then you have actual data in the database. When you migrate data, it's essentially a migration of data, although you're using these two sources in combination to one another, but these are two different sources. So what is the challenge? So let's actually discuss that challenge. When you move your data from a data source into a into a distributed cache to achieve more performance, more scalability, and more reliability into the system, let's actually quickly discuss what are the challenges that you see. Before we move on, we'll quickly talk about types of data that you can cache. It could be reference data, it could be transactional data. It's more of a read intensive data that you cache. Usually it belongs in a relational database. It's not that it's not changing, it's not 100% static. It's changing data, but the frequency of that change is not that great. So that would categorize as a reference data. And then we have a transactional data, which is changing very frequently. As frequently as in few seconds, few minutes, or in some cases it could be in few milliseconds. And then most cache data is relational. It's brought from a relational database. And I've already discussed that you have data master copy in the relational database, and then you have a subset of that data, reference and transactional, brought into the distributed cache. Right, so what is the challenge? When you have a distributed caching system in place, it works very well. It improves your performance because it's in memory. It's linearly scalable, so it takes care of scalability issues with database. It's not a single point of failure because there are multiple servers and any server can be brought down. You can bring servers up without any issues. Maintenance becomes a lot easier. Your upgrades become a lot easier. So in comparison, you get a lot of benefits. But there is one challenge that you need to address, and you need to take that into account when you migrate your data or move your data from the database to the relational to the distributed cache and start using a distributed caching system. So distributed cache is a hash table like interface, right? It's each item is separated with a key and a value, right? So it's a hash table where items, each object in the cache or each item in the cache or a record in the cache is represented with the help of a key and a value. So it's not a table, or it's not a relational data where we have relationships, we have defined schemas, we have entities which have proper relationships among each other. It's going to be a separate key value item which is representing an object in the cache. So database has relationships between entities, and when you migrate your data or when you move your data from a relational database to a distributed cache, you lose that relationship characteristic of that data. So by default you don't have that ability. So that's one of the main challenges. And then there are some other associated challenges. Database query results into a collection of objects. It also results into a data table or a data reader. So dealing with data table and data readers in a distributed cache is not a good idea, right? So we'll actually go through all these challenges one by one. Primarily we'll discuss how to manage relationships in the distributed cache once you've brought data from a relational data source into the cache, how you go about that detail. So next we'll talk about the caching API. Now that we have discussed that it is basically a key value store, we have a cache.add where we have a key, my key, and then we have an object which is any permitted .NET permitted serialized object. It could be any customer object, product object, order object, but this is a very simple hello world kind of example where we call key value methods using cache.add, cache.insert to update. Similarly, we call cache.get to get the same item back, and then we call cache.remove. Any questions so far? We've covered some basic details about distributed caching, but please let me know if there are any questions.
Quick question, Ron. I see that you used my key just as an example. Do you have an example of a more like an intuitive example?
Yes, absolutely.
For a cache item key?
Yeah, that's a very good question. So this is just a hello, like I mentioned, this is a hello world kind of example, a very simple cache that get and a random my key, to use an example. The key construction is your your own logic, right? So you can come up with intuitive cache keys, such as a customer object can be represented with a keyword customer, and then it could have a customer ID appended to it as a runtime parameter. As a matter of fact, let me just show you this with the help of an example right here. So here we have a customer key, right? We are using a keyword customer that represents this object, that this is a customer object. That's the name of the object, the namespace as well. But it could be anything. It's your design, your application. And then the customer ID to notify that the next parameter is going to be the ID of that customer, which is usually a primary key in the database, and a customer ID, an attribute in the class. And then customer ID is the runtime parameter for that particular customer. And then you store that one customer with this cache key. So you can get creative with that. It's your application. If you're storing customers, you can use customer keyword. If it's orders, you can use order keyword. Products, if it's a data stream, it's representing an environment, QA environment, you can even append those keywords on top of those objects. But the idea here is that you arrange these objects into key value pairs, and key is something that you control inside your application, and you can get creative with that. So this is one good example. There could be more. For example, orders of a certain customer can be represented with customer orders, and then customer ID is representing those orders with the help of a runtime parameter. I hope that answers your question. Moving on, so how to manage relationships in the cache. Now that we've defined this challenge, that cache is a hash table like interface. It's a key value pair. Value is .NET object, and key is a string key which you format, and these are independent objects from one another. And database has relations, tables, which have relationships with one another. It could be a one-to-one, one-to-many, and many-to-many relationships between different tables. How to map those relationships onto the distributed caching objects. So first step, there are two things that you should consider doing. First of all, you should consider using the cache dependency, and we're primarily focused on key-based dependency. That's one of the features, and I'll show you some code examples around that, which helps you keep a track of one-way dependency between the cached items. So you could have one parent object, and then you could have a dependent object on that particular object. And the way it works is that one item depends on another. The main item, the primary object or the parent object, if it goes through a change, it gets updated or removed, the dependent item automatically gets removed from the cache. A typical example which I have lined up in upcoming slides is a list of orders for a certain customer. So you have a customer A, it has list of orders, say 100 orders. What if that customer is updated or removed from the cache? You don't need those associated orders with that. So you might want to do something around those orders collection as well. And that's exactly what this dependency is for, that you need to have a linkage between these two records, since these are related in the relational database. Then this dependency can also be cascaded in nature, where A depends on B and B depends on C. Any change in the C would trigger an invalidation of B, and that would in turn invalidate A as well. So it could be a cascaded dependency, and then it could also be multi item dependency as well. One item can be dependent on item A as well as on item B, and similarly one parent item can have multiple child items as well. And this was a feature initially introduced by ASP.NET Cache. It was one of the important features that NCache also has. We provide it as a separate cache dependency object, one of the dependency objects, and this is going to be the main focus in this particular webinar. Second step, in order to map your relational data, that's one other challenge that we recommend, that you actually should map your domain objects onto your data model, right? So your domain objects should represent a database table. You should use some kind of OR mapping. You can also use some OR mapping tools. It simplifies your programming. You can reuse the code once you've classes mapped onto your database tables. You can use even the OR mapping tools such as Entry Framework and Hibernate as well. These are few popular tools. The idea here is that you should have classes in the application, the objects in the domain objects in the application. So your database objects, data tables or data readers, are transformed, mapped onto the domain objects. So a customer table should represent a customer class in the application. Similarly, order collection or order table should represent order class. in the application, and then those are the objects that you deal and store in distributed cache and formulate relationships with the help of key dependency. Let's take an example. We have our database model from Northwind. We have customer table, we have order table, and then we have product table. We have all the column names of the customer. We have customer ID, company name, phone, city, state, country, some attributes. Similarly, we have product with product ID, name, price, units in stock, units on order, reorder level. So those are some attributes or some columns from the product. And then we have order table as well, which has customer ID and product ID as foreign keys. That's formulating a primary key, a composite primary key. And then we have order date, ship date, some attributes of order itself. And if you notice that there is a one-to-many relationship between customer and order, and then there is a one-to-many relationship between product and order. Similarly, we have many-to-one and many-to-one between order and customer, and order and product respectively. So we'll tackle this particular scenario. Initially, it was customer product many-to-many relationship, which got normalized into two one-to-many relationships. So this is a normalized data model, and we'll use an example of this where we have a class, a domain object mapped onto this particular data model. So we'll talk about primary object in a bit, but let me just quickly show you the example here. Notice that we have domain objects mapped onto our database model. For this same example, we have a customer class which has customer ID that is going to be used as a primary key, and then we have a collection of orders which is representing a one-to-many relationship with the order class. Similarly, we have a product which has product attributes, same as these: product ID, name, unit, price, right? And then we have orders collection here as well, which is representing a one-to-many relationship. And on the order side, we have the customer ID brought from here, product ID brought from here, and then we have ordering customer, the customer many-to-one relationship, and then we have ordering products, a many-to-one relationship captured as part of the domain object. So this is one of the techniques that I'm going to cover in great details in upcoming slides. Let me show you these objects within Visual Studio as well. So this is one of the class. One thing that I would recommend is that you decorate these classes with serializable tag, right? So you need to cache them, right? So these domain objects should be serialized because these are the ones which are going to travel back and forth between your client application and the distributed cache. So we have customer class, we have product class right here, a list of orders, and we have order class which has all the attributes as shown on the presentation slide as well. Next, we'll talk about primary object. Now that we've shown some domain objects which are mapped onto the domain data model, we'll show you some techniques to go over one-to-one, one-to-many, and many relationships. So first of all, I'll talk about a term which I'll be using in upcoming slides. Primary object, it's a domain object. It's mapped onto your database. It's a starting point of your application. For example, you have a customer object, and then if you need orders, you need the customer to start off, right? So it is the first object that your application fetches, and all the other objects which are related to this are going to be brought in relation to this, right? Another example could be if you're processing the orders, right? So you might want to fetch orders in that processing unit, and then you would like to know about the customer who ordered it to dispatch that particular order, right? So in that case, order becomes your primary object, and then it has a many-to-one relationship, or it has a relationship with one of the customers who actually ordered that particular order, or all the products within that order. So it's going to be one way or other, but we'll be giving we'll be using a primary object that will cache, and then we'll make other objects dependent on that. That's the approach that we'll follow. So let's actually get started with this. And by the way, any questions so far, please let me know if there are any questions. I'll be showing some code examples from this point onwards. So if there are any questions so far, please let me know. Alright, so first of all, we'll talk about one-to-one and many-to-one relationships within the distributed cache. That's the most common scenario, right? So one option is that you cache related objects with primary object. Now that you've seen our domain objects, we have a list of orders as part of the customer. So if we populate these orders and customer has those orders as part of it, if you store customer as a single object in the cache, that has all the orders as part of it, right? So that would get the job done. So here's a code example for it. We have a cache order. We set the ordering customer within the order to null, right? So we don't have a orders also having a reference to customer is redundant. This is not a very good programming practice, but this is just to enforce we don't want cache orders from customer and product, right? So we just want to have one customer added in the cache, and then we would just like to have orders as part of that. So let's have a look at this. Right, so we set this to null and then we simply store it, or if we don't set it to null, this can actually have a reference back to that. Similarly, if we have a customer, right, so if we don't set the order to null, although this is a separate object, but if we just simply store this customer, let me just take you to this. Since it has a list of orders, if we simply store this customer as a single object in the cache, it has a orders collection as part of that object. Although I'm setting it null for another example, but just to show you this particular case, you can store one big object and it would have all the related objects as part of that object. So you need to start from your domain object. You should have your relationship captured as part of the domain object, and you should do that regardless. And after that, you should cache, you should actually have a populated list of orders, list of related object as part of that. So this is the simplest approach that you can get. There are some benefits of it, that you have one object which is representing everything, but there are some drawbacks as well. It would be a bigger object in size. Some cases you just need customer, but you would end up getting orders as part of that. You'll be dealing with bigger payload, and you don't have granular orders as separate items in the cache, so you would have to deal with collection of orders all the time, although you're interested in only one order, right? So that is one approach. That's a starting point. Second, you cache related object as a separate item in the cache. An example for that is the order class, where we have cache order. Right, so this is the example where we have a customer first of all, right, and then we're storing customer as a single object. You can see that we got the order, and then from order we extracted the customer, and then we set the orders collection within that customer object to null, right? So this is something that you should do within the constructor, but that's being done here just to enforce that, you know, that this customer object does not have this order as part of that. And then you store this customer as a single object. What we're doing here is that we're creating a customer key, which is customer ID, runtime parameter, and then we're storing a customer as a single object in the cache. Next thing that we're doing is we're creating a cache dependency. So we talked about two steps that we wanted to do. One step was that you map your data model onto your domain object. So your domain object should represent a table in the database, and then once you plan on caching those, you have primary object, in this case it's customer, and then we have orders which are related to the customer in a one-to-many relationship. You create a dependency between customer and the orders collection with the help of a cache dependency object. You create a cache dependency. This same cache dependency takes two parameters. First one is file, right? So it can be dependent on the file name, and it can also be dependent on the key, right? So we set it to first parameter to null, so we don't want it to depend on any files. That's another feature that within NCache, where you can make items dependent on a certain file system, certain files on your file system. And then if you use the key-based dependency, it needs the key of the customer on which the parent item of the parent item on which the child item is going to be made dependent upon. And then we construct the order key of the collection of the order. We have the entire order collection right here, which is passed on to this method, and then we simply call cache.add and or add order. Now customer and order are related to one another. We have a list of list of orders from this customer, which are represented as a separate object in the cache. So whenever you need all the orders of this particular customer, you just need to use this key. All you need to do is call, let me just actually use this example right here. I'm sorry. You can call cache.get, right? And then you simply pass on order key, and this would fetch you this particular order that we constructed within this method, right? So that's what you need in order to fetch all the collection of all the orders of this particular customer at once. But what if the customer goes through a change? If the customer gets updated, the orders collection does not need to stay in the cache. It can either be removed, or in some cases it can also be updated, right? So that's our approach number 2, which is more sophisticated in terms of storage, in terms of usability, and it also maps 2 records in a relationship, a one-to-many relationship or many-to-one relationship. It could be other way around as well, which we'll cover in a bit, where you can have list of orders, and each order can be mapped onto those individual orders can be mapped onto those multiple orders can be mapped onto a customer, uh, if the order is the primary object for that particular application scope. Now this defines a relationship between customer and orders. Any questions so far? Please let me know if there are any questions.
Just a quick question for you, Ron. When one of those cache dependencies is invoked, is there a way to get notified if a dependent item is removed?
Yes. First of all, we also provide callbacks, right? So cache dot item added, item removed. These are the callbacks that you can get. These are the callbacks for that you can actually set up, right? Right. So you can actually have a cache item remove callback for a certain key, and then that callback could actually be based on the key of that item, right? So you can have an item removed callback set up for this particular key, and that would work in such a way that if the item gets removed, you get notified, right? Obviously the dependency would be invoked on the server end. NCache is keeping track of these relationships. So if the parent item goes through a chain and the collection has to be removed, if you want to get notified, you can even get notified on the customer getting updated or removed, and then you can also get notified on the related object being removed without your application knowing about it, right? So it would just send you a callback for that matter. So that would take care of it. And a few more details around cache dependency feature. If I go here, it's first of all exposed but with the help of lachi.ncache.runtime.dependencies, and this is one of the overloads that you use, and you simply use this particular method right here. And the behavior of this is in such a way that it allows you to simply track one-way dependency between objects, and it could also be cascaded as discussed earlier in the presentation. Next, we'll talk about one-to-many relationships. Since we talked about one-to-one or many-to-one, where we had order and then we had a customer. So this is similar to one-to-many in most cases, but since it was starting point was order, and then we structured the customer, stored the customer, and then we stored the collection of orders, and then we defined a many-to-one relationship between orders collection and that customer. Now, one-to-many relationship, that's going to be very similar to what we've discussed. First option is that you cache related object collection as part of the primary object. So customer is your primary object, order should be part of that. Second item is that your related objects are cached separately, but individual items in the cache. Right? So this is collection, which is separate. We have orders. We got a customer object here, one-to-many. And customer has orders. We got the orders collection out of it, and then we set the customer.orders to null. So customer is an independent object, a primary object. Orders collection is a separate object, and then you store the customer, create a cache dependency, and store the orders. So it's going to be a one-to-many, the entire collection. Second approach is that this collection can also be broken down. The orders collection can be separate. Each item within that collection could be separate item in the cache. So in this case, we would just use the same approach. We'll get the customers, we'll get the orders, we'll store the customer, we'll create a dependency of that customer using key dependency, and then we'll iterate through all the orders. Let me just go through cache customer method right here because it's more intuitive here. So we get the orders collection out of it. We set the customer orders to null, so customer is only about customer. Store the customer in the cache using cache.add key. Constructed a cache dependency around that particular key of the customer, and then we simply iterate through. There's a loop around here. We should actually iterate through it, and this is actually better. We iterate through it, and then we simply store it at once, as individual items in the cache. So order has its own key. In each order is a separate item in the cache. And then one other thing that we've done is we've actually grouped these. We've called cache item.group, and customer ID is a group as well. So we're actually managing a collection inside the cache as well. Let me see if I have, there you go actually. For example, we have this right here. We could actually cache these products. That's another example, by the way, where we have looped around all the product collection, and then we've stored them individually, and then we've actually we've put everything in a group, right? So this product, which is being stored as a item, can also be stored like this, where we have a prod cache item. My keyboard is playing up, so please bear with me. Let's just use this for now, and then I'm going to simply, I can actually add a group dot group. So this is allowing, this would actually allow me to set a group for this. Let's say dummy group. Now if I stored this cache item, and it could actually have a product as a item for this, right? So instead of storing the actual raw object, I can even arrange it in a group. I can simply use product cache item. There you go, right? So now it is actually being, or instead of using the dummy group, let's say product group, right? And when I need to fetch this, I can simply use product group, and it would fetch me all the items of this collection at once. Although these are being stored individually, these are individual cache.get calls. Individual products within the product collection are stored individually, but I can arrange them in a group, in a collection, and then I can fetch them. But nice thing about this is that it's still using a dependency, right? So it's using a dependency of one customer on those individual items. So let's take an example. We have one customer, it has 100 orders. So total, we would have one item for customer in the cache. We would have 100 orders separately stored as 100 items in the cache, and there is a one-way dependency between that one customer and 100 orders. If you remove that one customer out of the cache, 100 orders would invalidate at once. And now you have a benefit of fetching individual orders if you need to, so you can interact with those items individually, one item at a time. You need a certain order, you can process it, and when you need the entire collection of those orders at once, you can simply call cache.get group data and provide the product group, and then subgroup could be anything. It could be null even, and then you can also use the tag. For example, the other way of managing this is that you use the product item and you create a tag for it, right? And then you there is a, yeah, there it is, and you can provide a tag which can go something like product tag, right? And then you can associate this as part of that. So this would actually work on the same lines, and then you can also call get by tag methods, and that would take care of all the items at once. It would bring you all the items at once. So this would give you a more control on your arrangement of data in the cache, and then still keeping a one-to-many relationship intact. Any questions on this approach? So this takes care of one very particular scenario where we have one-to-many relationship, and we have one object added, and then we have those items on the many side, that collection stored individually, items from that collection stored individually in the cache, and then you still have a dependency, and then you still have a collection type of behavior for that with those related items. So those items are related to one another, they're forming a collection, and then they have a relationship with another object in a one-to-many formulation. So this code snippet, very simple, intuitive APIs, takes care of all these scenarios. You have one-to-many relationship captured with the help of key dependency. You have arranged those items individually in the cache, but you've still put them in a logical collection of groups or tags. And then when you need those items individually, you call cache.get, right? So one way of getting this item is that you call cache.get, right? And use the key, which is product key here, right? So this would fetch you this particular product that's being stored with this particular key, right? And the other option is that you need all the items within that collection at once, so you can use cache.getGroupData. So it can give you a collection behavior, and at the same time it can also give you uh, 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 individual management of those related items. So that should take care of collections and items within the collection and one-to-many at once. Next, we have many-to-many relationship. Many-to-many relationships don't exist typically in the domain objects. It's always going to be normalized into two one-to-many relationships in the database as well. As a matter of fact, we had a many-to-many relationship between customer and orders, customer and products, many-to-many relationship, which got normalized with the help of an intermediary object into two one-to-many relationships. So we have one-to-many here and many-to-one here between customer and order to product respectively. So that's how you would deal with many. So it would end up using either one-to-one, many-to-one, or one-to-many relationships. Yeah.
A question?
Please go
ahead. We have a member of the audience that has a question, but on their behalf, he wrote at one point the use of tags caused performance issues. Is this still the case?
All right. So tags are indexed by design, right? So I'm not sure what version of NCache had that particular issue, but tags, this is one of the very most commonly used features of NCache, right? And the nice thing about this feature is that it's indexed behind the scenes by NCache, right? So you don't have to go through configurational details around that. You just create a tag and then add it on top of an object. So it's a logical attribute sitting on top of your objects. It allows you to create a collection, and then it's the query on the tag and the tag based APIs should be faster in comparison. The reason this should be faster in comparison, because it's dealing with a collection, but it's dealing from the objects which are indexed. So these are maintained separately in NCache. One challenge could be that once you're adding an item with the tag, it actually needs to add an object, and then it also needs to maintain a tag and an index for that, right? So that may give you some overhead on add or update calls. But as far as retrieval is concerned, it's going to be super fast in comparison, and we actually have some tests around that. So that should support that. If there is a particular issue with tags where you had some very specific performance challenges, please get in touch with us and we'll help you tune that. But as far as architecture is concerned, retrieval part should be super fast in comparison. Where you're dealing with collections, so a tag should be more optimized. So this should take care of your many-to-many relationships. Next is that you handle collections. We've already touched this with the help of our product example, but I'll still go through it. That you cache entire collection as one item. For example, you store the product. Let's go through it. Right, so you have cache products. So you create a product key, and then you have a list of products which is being brought here, and then you cache them as a single object. And like I explained earlier, it is going to work. It would just get you the job done, and it would work mostly when you need all the items from that list at once. You're not interested in individual items from that list. You're interested in entire list. So just in that case, store entire list as one item. But it will make the object heavier. It would not give you support of querying, searching, and that's our next topic, because it's a generic list, iList. It has a product in there, but for NCache, this is just a list, iList, right? So you're not able to pinpoint the object within that list and then attributes, and then you don't have ability to search based on those attributes. So a more sophisticated way of handling this is to cache each collection item separately, that we covered as part of our earlier example, but let's go through it one more time. For example, let's go through cache products one more time. In this, you simply store them as individual items. Let's see. Let me find this example for you. All right. Okay, there it is. So first of all, we'll actually store products individually, right? We'll have a key constructed around that for individual products. Nice thing about this is that all individual items of product collection are stored as individual items in the cache. So you can fetch them using the key. That's the overload for that. The method for that, cache.get. You can fetch them as a collection as well. That's something that we discussed in great details. One other option is that you also run queries, and these SQL like search queries can be applied on the attributes of the objects directly, and you can only do this if you have stored them individually. All the items within a collection are stored as individual items. You map them onto a domain object, product in this case, and the products within a product collection are stored individually as separate items in the cache. Now you can index the unit price of the product ID, and then you can run a query like this: select product, that's the namespace of the product, where this unit price equals to a runtime parameter, and then you can call cache.execute reader, and that would fetch you all the products, which you can iterate through and keep fetching in your application as well. Similarly, you can also say where this dot tag, if you have associated a tag on top of it, you can also run queries on that. That's another benefit of tags. Along with retrieval benefits, performance benefits, it also gives you flexibility on from a searching standpoint. And tags also give you cache.get by tag. It gives you all the APIs, get by all tags, get by any tag, so you can actually fetch objects using these tag APIs as well. But the feature that I wanted to highlight is that you arrange them individually. That's the starting point. You create logical collections using tag or groups, so retrieval is easier. You need individual items, you call cache.get, get the items based on the key. You need collections, use the group or tag APIs, and on top of it you can run queries, and you can actually fetch items based on a criteria. In this case, it could be unit price. It could be unit price greater than 10 and less than 100. So logical operators are supported. You could have some aggregation as well, count, sum. There are some sorting, order by, group by, like operator, in operator. So it's pretty extensive as far as support is concerned. It's similar to SQL. It's a subset of SQL queries, but it's very flexible in usage, and it gets you a lot of ease of use in terms of what items you need. You don't need to work with keys anymore. So that would only happen if you simply use each collection item is stored separately in the cache. I hope that helps. That completes our topic today. Please let me know if there are any other questions. Towards the end, I'll just show you 5 simple steps to getting started with NCache, to just go over NCache configurations and then be able to run these APIs in a real life application. So please let me know if there are any questions so far. Okay, so I'm going to quickly get started with this. I have the management tool opened. By the way, we just released 4.9, so that's our newest version. So you might want to get started with that. So all you need to do is create a cache, provide the name of it, choose next, pick a caching topology. Partition replica cache is most suitable. Async option for replication, and here you specify the servers which are going to host this cache. I have demo 1 and 2 already installed with NCache. So step 1 is to download and install NCache. Step 2 is to create a named cache. So I'm going to go through it. Keep everything default because that's not the main scope of discussion today. I'm just going to go over with default values and size of the cache, which is on each server. Just set up the basic settings and choose finish. Step 3 is that you add a client node. I'll just use my machine. Let's see if I have access to this. Yeah. Alright, so that's my machine right here. I'm added that. So step 3 is complete. All the configurations on the server end and client end are complete. I now need to start and test this cache cluster as part of my step 4. And then I'll review this and then use it in actual application. So that's how simple it is to get started with NCache. I'll show you some quick counters to show you things in action, and then we'll quickly conclude the presentation as well. I'll right click and choose statistics. That would open performance counters, and I can also open monitoring tool, which is NCache monitor, comes installed with NCache. So it's performance counter driven. It gives you server side performance counters and client side performance counters as well. And on the client application side, I can run this stress testing tool application, which again comes installed with NCache. It takes the name since there are configurations done, so it would automatically connect to the cache and start simulating the load on my cache cluster. There you go. So we have request load coming here as well as onto the other server. Similarly, we have activity being shown on this server as well as clients connected, report view of server and client, and then you can also have your own custom dashboards where you can plug in any of these counters. For example, API logs is a good example. It logs all the requests which are being performed on the cache right now in real time, right? So that's one quick example of using these counters from the left main. Like I said, this is just to get you a feel of how the caching looks like. Now I can actually use this in a real life application. I can use my machine right here, and I can simply use basic operation sample, which comes installed with NCache. All you need to do is, there are different folders within samples.NET basic operations. As far as using NCache client-side libraries, you can use NCache SDK NuGet package. That's the easiest to get all the client-side resources. The other option is that you actually use apache-sort.ncache.runtime and apache-sort.ncache.web libraries yourself. You include those. These are these are the libraries which come installed with NCache in Microsoft GAG folders. Once you install NCache, it would be part of it, and then after that I'll quickly show you what you need to do. There you go. So first thing that you need is add references to these two libraries, runtime and web. Include these namespaces, which I just highlighted. Not able to highlight. Yeah, web.caching, and then from that point onwards, this sample is pretty good enough for basic initializing the cache, connecting to it, creating an object, reading it, deleting it, updating it, all sort of create, read, update, delete operations. So this is how you initialize the cache. This is the main call, right? It needs a cache name, returns a cache handle, and then simply call cache.add, store everything in a key value pair, cache.get to get items, and then to update items, cache.insert, and you call cache.delete. And we've already shown you some detailed examples of using key-based dependency, using tags, using groups, using SQL-like search. So this should actually give you some details around setting up the environment and then be able to use it in an actual application. Any questions? We still have about 6 minutes, so please let me know if there are any other questions for me. This concludes the technical portion of our presentation, so please let me know if there are any other questions.
All right. It does not look like we have any other questions. So unless you have anything else, Ron, I'll wrap this up and put a period on it.
Yeah, please go ahead.
Okay, well, thanks everyone for joining us. We appreciate your time this afternoon. If you think of any questions after we conclude the webinar, Ron has the slide up. There's our email addresses and phone numbers. Feel free to reach out. If you're interested in a one-on-one demo of the product itself, also let us know, or have any technical questions about your particular use case. We have a team of architects that would love to hop on a call and discuss your scenario. And just to elaborate quickly on, Ron made a comment about we just released 4.9. When he said just, he meant hours ago. So that is hot off the presses per se. I do have a little bit of a cheat sheet here. There's a couple of major enhancements. One's recovery from split brain. So anytime there's a situation where a subcluster goes down, the cache clusters will automatically recover from a split brain scenario. ASP.NET Core response caching. So it essentially dramatically improves the performance of your .NET Core app. There's just overall performance enhancements, about a 20 to 25% improvement as far as the performance and speed of the application. And then the big news was the more features in open source and community edition. A lot of the developer tools that are available, that were only available in enterprise, are now in open source and community. So it's definitely by far the most powerful solution that we've released in the history of NCache. So it's on our website. You can download it if you choose. And again, if you have any questions, let us know. We're here to help, and we work very closely with our customers during their evaluation. So yeah, we hope to hear from you again. Thanks for joining.
Thank you very much, guys. Thank you.